At 2:37 a.m., deep behind the front line, a Russian supply hub that had operated for months in near silence suddenly lit up the night sky. What began as a single flash turned into a chain reaction. One explosion, then another, then dozens more, each blast feeding the next. Satellite sensors later recorded heat signatures lasting over an hour, a clear sign of secondary detonations. This was not a frontline trench or an armored column under fire. This was the logistical heart that kept artillery firing, vehicles moving, and units supplied. Ukrainian missiles had reached far beyond the battlefield, striking where Russia least expected an attack. Within minutes, roads were closed, rail traffic halted, and emergency crews struggled to contain fires spreading across fuel and ammunition storage areas. If a war is sustained not by soldiers alone, but by what feeds them, what happens when that lifeline is cut in a single night? Since the early phases of the war, Russia's military strategy has relied heavily on centralized logistics. Ammunition, fuel, spare parts, and replacement equipment are typically stored in large depots positioned well behind the front line, then moved forward by rail and truck in a steady, predictable rhythm. This system is efficient when protected, but fragile when exposed. Unlike dispersed Western-style logistics, Russia's approach concentrates resources, creating powerful hubs that function as arteries for entire sectors of the battlefield. The supply hub struck that night was not chosen at random. It sat at the junction of a rail spur and a regional highway linking rear area depots to multiple frontline formations. From this single location, fuel-fed armored units, ammunition-sustained artillery batteries, and spare parts kept vehicles operational. Analysts have long noted that when these hubs function smoothly, Russian forces can maintain high rates of fire. When they fail, momentum collapses quickly. Ukraine learned this lesson the hard way during the early months of the invasion, when its own logistics came under intense pressure. Over time, Kyiv shifted its focus from meeting Russian forces head-on to systematically degrading the systems that support them. Rather than attempting to destroy every tank or gun, Ukrainian planners increasingly prioritize strikes on command posts, bridges, rail nodes, and supply depots, targets whose loss ripples far beyond their physical footprint. Geography also played a role. The hub was located far enough from the front line to foster a sense of security, yet close enough to reduce transport time. Russian air defenses in the region were oriented toward protecting frontline units in major cities, not a logistics site assumed to be out of reach. That assumption reflected an earlier phase of the war, before Ukraine demonstrated the ability to strike deep with precision weapons. By targeting this hub, Ukraine was not simply destroying stored material, it was challenging a foundational belief in Russia's war planning that rear areas remain safe as long as the front holds. The strike signaled a shift in the battle space, where distance no longer guarantees protection and where logistics, not territory, increasingly define strategic success. The strike was the result of weeks of quiet preparation, not a sudden decision made overnight. Long before the missiles were launched, Ukrainian intelligence officers had been studying patterns rather than targets. Satellite imagery revealed when trains arrived and departed, how long fuel tankers remained on site, and which storage areas were replenished most frequently. Over time, a clear rhythm emerged, a logistical heartbeat that indicated when the hub was most vulnerable. Unmanned aerial systems played a supporting role, operating at the edge of detection to confirm what satellites could not. Short, carefully timed reconnaissance flights verified new construction, camouflaged storage revetments, and the presence of air defense vehicles that appeared and disappeared from the site. Analysts cross-referenced this data with intercepted communications and open-source indicators, building a layered picture of the hub's defenses and daily operations. Timing became critical. Ukrainian planners waited for a moment when the depot was near peak capacity, maximizing the potential impact of a successful strike. Weather forecasts were scrutinized as closely as enemy movements. Low cloud cover and limited visibility would reduce the effectiveness of visual tracking systems while complicating emergency response after impact. At the same time, planners needed stable conditions to ensure missile guidance remained accurate. Inside a secure operations room, the final decision hinged on risk. Every deep strike carries political and military consequences. A failed attack could expose capabilities or invite retaliation. A successful one could reshape the operational balance. Engineers reviewed flight profiles one last time, confirming terrain-following routes designed to minimize radar exposure. Officers synchronized launch windows down to the minute, aware that even a small deviation could give defenders time to react. When authorization was given, there were no speeches or celebrations, just quiet acknowledgement. The missiles would do their work in silence, guided by data gathered over weeks. For the planners involved, the outcome was uncertain, but one thing was clear. By dawn, the rear of the battlefield would no longer feel as safe as it once did. Shortly after midnight, the launch sequence began. Far from the target, Ukrainian crews monitored telemetry feeds and countdown clocks as the missiles left their launch points one by one. There was no roar audible near the supply hub. No warning sirens in advance, only shapes moving low and fast through the darkness. Flying at terrain-hugging altitude, the missiles followed pre-programmed routes designed to exploit gaps in radar coverage, skimming over fields, river valleys, and infrastructure corridors that blended into the background noise of civilian geography. Inside Russian Air Defense Command post, screens showed nothing unusual at first. The region had experienced sporadic drone activity before, and operators were accustomed to false contacts and fleeting returns. By the time anomalous tracks appeared, they were already compressed in time and distance. Alerts were raised, but confirmation lagged behind detection. This was the problem with defending rear area targets. Assumed to be low priority, reaction time mattered more than raw capability. The first missile struck the outer edge of the hub, punching through a storage area believed to contain fuel reserves. A bright flash lit the sky, followed by a deep, rolling shockwave. Seconds later, a second impact hit closer to the center of the complex. The effect was immediate and unmistakable. Flames spread rapidly, fed by ruptured tanks and ignited materials. Within moments, the initial blasts triggered secondary explosions, sharp concussive detonations that indicated ammunition cooking off inside storage bunkers. As fires intensified, the situation spiraled beyond control. Emergency crews attempted to respond, but were forced to keep their distance as additional detonations rocked the site. Rail lines leading into the hub were cut by debris and heat damage, while nearby roads were sealed off by security units, uncertain whether more strikes were coming. Above, the night sky pulsed with orange light visible from kilometers away. From Ukrainian monitoring stations, analysts watched infrared feeds register sustained heat signatures. This was the confirmation they were waiting for. A single contained explosion might suggest limited damage. What they observed instead was prolonged combustion, evidence that the strike had reached deeply into stored material. Each secondary blast multiplied the original effect, destroying assets that had taken months to stockpile. Inside Russian command channels, confusion set in. Reports conflicted. Some units claimed air defenses had intercepted incoming threats. Others reported catastrophic losses at the depot. The fog of war thickened as commanders struggled to assess what had been lost and what could still be salvaged. In the absence of clear information, precautionary measures followed. Nearby units were ordered to conserve ammunition, movements were delayed, and planned operations were quietly postponed. By the time the fires began to subside hours later, the damage was already done. What had been a critical node in the logistics network was now a smoldering complex of twisted metal and cratered storage areas. The missiles themselves were long gone, but their impact continued to ripple outward through supply schedules, operational planning, and the confidence of those who believed the rear was beyond reach. If a single precisely timed strike could generate this level of disruption, what did it reveal about the vulnerability of modern military logistics in a war defined by reach and precision? In the hours following the strike, Russian air defense units moved quickly to assert control over the narrative and to prevent further damage. Surface-to-air missile systems in the wider region were placed on heightened alert, with radar operators instructed to prioritize low-altitude contacts previously considered background noise. Mobile air defense assets were redeployed, creating a denser protective umbrella around remaining logistics sites and key infrastructure. Official statements soon followed. Russian defense authorities claimed that air defenses had intercepted the majority of incoming missiles, and that damage on the ground was limited. Such language was familiar, designed to project resilience and continuity. Yet these claims were increasingly difficult to reconcile with observable reality. Satellite imagery and thermal data released hours later showed extensive burn areas, collapsed storage structures, and scorch marks extending well beyond a single impact point. The challenge for Russian air defense was not a lack of systems, but a mismatch between design assumptions and the evolving threat. Systems optimized to protect cities, air bases, and frontline units struggled to provide comprehensive coverage for rear area targets spread across vast distances. Defending every depot, rail junction, and fuel storage site simultaneously was simply not feasible. Commanders were forced to make immediate trade-offs: protect the front or protect the supply lines behind it. In several sectors, this translated into delayed resupply and tighter ammunition controls as units waited for clarity on what had survived the strike. Firefighting and recovery operations continued under the constant fear of follow-on attacks, slowing efforts to restore functionality. The air defenses had responded, but too late to prevent the initial blow. The question was no longer whether the missiles could be intercepted, but whether the system as a whole could adapt fast enough to protect what mattered most. At the core of this strike was not sheer firepower, but precision and sequencing. Modern long-range missiles are designed to exploit the weakest points in layered air defenses, combining low observability terrain following flight profiles and accurate terminal guidance. By flying at low altitude and adjusting their routes to natural features, the missiles reduced radar detection time to a narrow window, often measured in seconds rather than minutes. From a tactical standpoint, the choice of target amplified the effect of each missile. Supply hubs concentrate fuel, ammunition, and maintenance assets in confined areas. When struck, the damage is rarely linear. Fuel fires raise temperatures high enough to detonate stored munitions, while blast overpressure compromises nearby structures that were not directly hit. This creates the cascading secondary explosion phenomenon observed after the strike, where the majority of destruction occurs after the initial impact. Cost asymmetry also played a decisive role. Even a high-end precision missile represents a fraction of the value stored in a major logistics hub. Months of accumulated ammunition, fuel reserves, spare parts, and specialized equipment can be lost in minutes. Replacing those assets is not just a matter of production, but of transportation and time to resources that become increasingly scarce under sustained pressure. Air defense systems, while technologically advanced, are optimized to protect priority points, not entire networks. A missile intercepted near a city or airbase is a tactical success, but protecting every rear area depot would require an unsustainable density of sensors, launchers, and crews. As a result, defenders must accept gaps that precision weapons are designed to find. The strike also highlighted a broader shift in modern warfare. Victory is no longer defined solely by territory seized or units destroyed. Instead, it is shaped by the ability to disrupt systems, logistics, command, and tempo. When supply flows slow, artillery fires decrease. When fuel is scarce, maneuver stalls. A single well-planned strike can therefore impose operational costs far exceeding its immediate physical damage. This is the emerging logic of precision warfare, where timing, intelligence, and target selection matter more than mass, and once demonstrated, such vulnerabilities cannot be unseen. The immediate effects of the strike became visible within days. Russian units operating in sectors supported by the destroyed hub began to experience delays in resupply, particularly in ammunition and fuel. Artillery fire rates, which depend on steady logistical throughput, were reportedly adjusted downward as commanders shifted to conservation mode. Planned movements were postponed not because of enemy pressure at the front, but because the rear could no longer keep pace. In the short term, Russia was forced to reroute supply lines. This meant longer transport distances, increased fuel consumption, and greater exposure to interdiction along secondary routes. Each additional kilometer added friction to an already strained system. What had been a relatively efficient pipeline now became a series of vulnerable links, each requiring protection and coordination. The longer-term consequences extended beyond the battlefield. For Ukraine's partners, the strike reinforced the strategic value of precision weapons used against high-impact targets. It demonstrated that limited numbers of long-range systems, when paired with accurate intelligence, could generate outsized effects. This assessment fed directly into ongoing debates about range restrictions, target selection, and escalation management. For Russia, the attack underscored a growing dilemma. Dispersing logistics reduces vulnerability, but increases complexity and cost. Concentrating supplies improves efficiency but invites catastrophic loss. Neither option offers a perfect solution, especially under constant surveillance. Perhaps most importantly, the strike altered perceptions of depth and safety. Rear areas, once considered relatively secure, were now part of the active battle space. Commanders had to plan not just for what lay ahead, but for what could be struck behind them. In a war increasingly defined by reach, the distance between front and rear was shrinking fast. The strike on the Russian supply hub was not defined by the size of the explosion alone, but by what it revealed about modern warfare. A handful of precision-guided missiles guided by intelligence and timing achieved what large-scale assaults often fail to deliver: a decisive disruption of the enemy's ability to fight. No ground was seized, no front line breached, yet the operational impact was immediate and far-reaching. This event illustrated a fundamental shift. Wars are no longer decided solely where soldiers meet, but where systems intersect. Logistics, once a background function, has become a frontline in its own right. When fuel stops flowing and ammunition runs dry, even the most heavily armed units lose their effectiveness. In this context, rear area targets are no longer peripheral, they are central. For military planners worldwide, the implications are sobering. Protecting every critical node is impractical, yet leaving them exposed invites paralysis. The balance between efficiency and resilience is becoming harder to manage as precision weapons grow more accessible and intelligence becomes more transparent. What once required air superiority in mass now demands only reach data and patience. For observers, the lesson is equally clear. The most consequential moments of a war may unfold far from the cameras in places few people ever see: rail yards, fuel depots, and storage facilities whose names never make headlines. Yet their destruction can shape campaigns and alter trajectories. As conflicts continue to evolve, understanding these dynamics matters more than ever. Because in the wars of today and tomorrow, the battle is not just about who advances, but about who can keep moving at all. Bye for now.